Okay, there we go. I will scroll back up to this to start with. And I want to remind you guys, which I'll send out the message today, but I want to remind you guys that we're taking the test during class tomorrow. And I purposely set it up so that it should be able to be done within that class hour without any issues. Basically, all of your classwork needs to be done by tomorrow night, because Wednesday morning is when I'm going to put it in the grade book, and then I'm not planning on looking at it again. So I've just got too much to do, especially because I've got to start prepping for the next, hex semester. So, because I checked Khan Academy this morning, and I don't particularly like having to call out people individually, nor do I have to I don't like having to email your parents or call your parents, because you guys are, for the most part, juniors and seniors, and you're awfully close to basically living on your own very soon. And this is kind of the point in your life where you should be taking responsibility for yourself. So I usually give you guys some leeway to try to take care of it by yourself. But there's an awful lot of people who haven't even started any of the work for this chapter. And I guess I'm hoping there's a reason behind it. But, it's going to be awfully difficult for you to take the test tomorrow, I guess, is the issue if you haven't really tried any of the practice work. So, again, I'll highlight the fact that I need you to take the test during class tomorrow. Now, I know there was one person who said they needed to take it later. I can't remember who that was, though. I'll go through the list and see if I can remember who it was. And that's fine. If you need to do something different, then let me know. During class today here, I'm going to teach you the last item from the unit, which is higher order derivatives. And honestly, I don't think you're going to have any kind of issue with that. But, whatever. I'll still teach it. And then any kind of time we have left after that, I'll help you out with any kind of questions from the outline that you want me to go over, or do some examples of, or whatever it is. So higher order derivatives, multiple parts to it, I guess, but the most common place that you will see higher order derivatives is position, velocity, and acceleration. That's the most common place you will see it. So I'm sure some of you guys are in physics, or have possibly taken physics last year. Yeah. No, you're more than welcome to interrupt. I like how I was pointing out all these things on the outline of the screen. There you go. Hopefully that works out. So higher order derivatives, just the most common location you ever will see it is position, velocity, acceleration. So I can go over the one for free fall, because if you're in physics, that's probably the one you're really used to. But instead, I'll just kind of make up a random equation and go with that. So position, for whatever reason, they usually refer to it as S of t. And let's just go with 8t squared minus 4t plus 3. just a random equation. Well, this answer, position, let's come up with a unit. Let's just say meters. Okay. If I take the derivative of position, and the actual equation itself isn't that big a deal. Do you remember what the derivative stood for? AJ, do you remember what the derivative stands for again? Perfect. That's exactly what I was looking for. So derivative, whenever you take it, represents the slope. Now, slope is change in y over change in x. Well, if I take the slope of position, the slope would be the change in y, which would be meters, but you'd be comparing it to time, because that would be the change in x's. And let's just say seconds. So if I take the derivative of position, my answer would be meters per second. And then that's usually known as velocity or speed. There actually is a difference between speed and velocity, which we'll talk about later. And then if I take the derivative of velocity, this is going to be known as the second derivative of position. This is what a higher order derivative is. If you take the derivative of a derivative. That's what they mean when they say higher order derivatives. So if I take the derivative of velocity, the slope of meters per second would be meters per second divided by seconds, which would be meters per second squared. So I know the slope is kind of a big deal, and you guys referring to it as slope doesn't always make it click. So slope always refers to how fast something changes. So if we want to figure out how fast your distance changes, well, then that's going to be the distance per time. So that's how fast your distance changes. Like 3 meters per second would be how fast your distance changes. And if we want to find out how fast our speed or velocity is changing, that's going to be known as acceleration, because it's the meters per second per time. So if your speeds are increasing, that would be like your acceleration increasing. If your speeds are decreasing or going slower, they're changing, they're getting slower, that'd be your acceleration slowing. So this is just the most common place you're going to see higher order derivatives, but we're going to use them actually all the time. This is just the most practical use of it. And I'm not trying to tie it too much into physics right now. A lot of times we do just because it's easy to see the comparison, like to see how it works. Let's just say you are given y equals 4 sine 2x. Now, there's all sorts of different notation, which is what I don't usually like. If you see this, so if it says y equals 4 sine 2x, find d cubed dx cubed. This isn't in function notation because I wrote y equals. So if it's not in function notation, this is often the notation you're going to see. Like d dx is normally how we say to take the derivative. If you see d cubed dx cubed, this refers to the third derivative. It basically means to do d dx 3 times. Now, sometimes this higher order derivative could be, an awfully horrible experience. I mean, like, if you think of an equation that has, like, product rule, if you do the product rule once, your derivative immediately has 2 parts. And then if you do the derivative of that again, you're going to have to do the product rule on each of these 2 parts. Most likely. And so then your second derivative would have probably 4 things. And doing the derivative of that would just get worse. So, on the AP exam, they frequently will give you a higher order derivative question on sine and cosine. And that's because sine and cosine are cyclical. They repeat each other. And so their derivatives aren't usually that bad. So, if I do d dx once, d dx of y would be dy dx. The derivative of 4 sine of 2x is going to be 4 sine of 2x. Oh, I got error. 4 cosine of 2x times the derivative of the angle, which would be 2. So dy dx would be 8 cosine of 2x. This is the first derivative. And if you want to do some kind of notation for yourself, just so you don't lose track of where you are, absolutely can do that. So that I'm going to do d dx a second time. Now here's the notation, which is kind of goofy. The derivative of the derivative is going to be d squared y dx squared. Which, it actually kind of works if you look at it, like d times dy, d squared y. It's not exactly how it works, but that's how easy to make sense. And then the derivative of 8 cosine 2x. Well, the derivative of cosine is negative sine. And then I would have to multiply by the derivative of the angle again. So this would be 16. And this is the second derivative. And theoretically, you don't have to what I'm writing in pink, you don't have to keep writing, because over here, the notation tells you where you're at. So you don't technically have to do this, but I was just, for you guys to keep, like not to get confused, you can. So I'm going to take the derivative the third time. And d dx of d squared y dx squared would be d cubed y dx cubed, which is what I'm trying to find from the original. That's like what the original question was. And derivative of sine is cosine times the 2 from the angle again would give me negative 32. Now, most likely once you get comfortable with this, you'll basically just be doing this in your head. Because once you see the patterns, then it's not as confusing. So sine and cosine are traditionally what the AP exam will give you to do higher order derivatives. Like, they might even say find the 25th derivative. But if that was the case, they wouldn't have a number multiplier in the front or something like that. They would just have a regular x as an angle so that it wouldn't get bigger as you go. But you can kind of see the patterns that it's following here. Every 4 derivatives, it repeats. Did this go okay? I should ask that. Does somebody want me to explain one of these steps that I did up here? Because I don't want to move on to more difficult, higher order derivatives if it's... Okay. So this is another common AP style question. And honestly, they're not terrible. There's only one step in it that people get confused at. Do you guys feel like you could find the derivative on your own already? I mean, why don't you take a minute and see if you can start this one. Find the derivative, because that's what d squared y dx squared is. It's the derivative of dy dx. See if you can do this derivative. This is going to require a product rule for that portion. Okay, I'll kind of cut you off there if you're not done. Because there actually wasn't much to do. So the way I wrote it, I kind of wrote it this way on purpose because I know some people, when they look at this, like it feels confusing as to what you should do for the derivative. So you take the derivative of every individual term. You know, the derivative of dy dx is d squared y dx squared. The derivative of 2xy is honestly the only one that has work. The derivative of x is 1. So the derivative of negative 2xy, everything there is being multiplied. So when I do derivative, I have to do product rule. What I did was let me shut my phone. I grouped together negative 2x as f, and then I did y as g. And you don't have to do it that way. There's different ways to view it. I've just found in the past most students feel like this is the easiest. So then off on the side I did f prime, g prime. And the portion that's easiest to forget is when you take the derivative of y, it's not 1, it's 1 dy dx. And so what I wrote here in white is, there actually was just basically like one step. Now the portion of this question that I'll call the confusing part is this would not be an answer on the AP test or in our textbook. So I don't know if any of you guys are using our textbook to try to do like, you know, additional examples or anything. This wouldn't be a correct answer. Like it's not like mathematically nice looking. And it's for one little reason, which to me is kind of excessive, but well, it's not up to me. So because dy dx was written in the answer, we know what dy dx equals. So your final multiple choice answer would actually not have dy dx written in it. And this is how they do it on the AP test multiple choice. Is they would take the equation from dy dx and put it in place of dy dx so that your entire derivative or second derivative could be written in terms of x and y. And you can multiply that out, simplify it however you want, but your entire second derivative, the mathematically correct one, would be in terms of x and y only. And that only happens, the only time this situation happens is if you have dy dx in your answer, like in the simplified answer. And if for some reason you had to go to, no, I won't say. I was going to say if you had to go to third derivative, same thing would happen. You'd end up with dy dx and you put it in place of that. I don't know. I'm trying to think if there's anything more for higher order derivatives. 99% of the time, you're going to see higher order derivatives. It's going to be in function notation, and it's usually straightforward. Like it'll say f of x equals some equation, and then the question will say find f double prime of x. And that would be the second derivative. Now in our next chapter, actually, it must be unit 4. We're going to learn all about like what the second derivative represents, like how to use all that information. So we're going to learn things that are called like the first derivative test and the second derivative test, and it's all about us learning how to use that information. But for right now, you're just supposed to try to get comfortable finding second derivatives, and most people are okay with it because it's just the derivative of the first derivative. What I showed you guys was kind of like the excessive examples that you're going to run into. The downside about these compressed time lessons that I got to give you is I can't talk about straightforward examples enough, and I kind of almost have to show you more difficult ones all the time. So let me go back up to here, because I don't want to use up all your time on second derivatives, which, you know, as much fun as there is only one of 12 questions on the test. I'm going to guess you guys have had a chance to try some of these outline, like to look through the 12. Is there some of these 12 you would like me to go over, or to maybe make up some examples to try with you? Who was it? Was it Dan? Were you the one asking? Sounded like you... Was there one in particular you wanted me to do? Yep. Let's see, Dan, what might work best? The one you took a picture of, why don't you email it to me? I can open up mine on my other computer. Doesn't matter to me. Okay. Okay, that's pretty much actually number 7. The only difference being, like, chain rule would mean, like, this might have, like, you know, like a parentheses cubed and something inside of it. So, but it's the same setup. So finding dy dx. And Aiden, I think that was you that asked this one, right? Or tried number 7? Okay. Traditionally, implicit differentiation just means it's going to be an equation that's not y equals. And then the main focus is that you need to take the derivative of each term separately. Now, for some people, this makes it easier. For some people, it makes it more confusing because it almost feels like things are just thrown at you. I try to take it little by little, I guess. That's just what helps me. So my derivative of x is going to be 1. I'm going to take the easiest ones, I guess, to start with. My derivative of 2 is 0. Just so you guys know, the most common mistake I actually see is someone will accidentally write 2 instead of 0. Because it's like you go through this problem so fast, you focus on the hardest things, that it's actually really, really easy for you to overlook this 2 and totally forget to even do it. So that's actually the most common mistake I will see. Derivative of 2xy means you're going to need to do chain rule, or product rule. 2x would be f, and then y would be g. So f prime would be 2, g prime would be dy dx. So my product rule for 2xy would be f g prime sub 2x dy dx. I'm going to run a Rome, aren't I? Plus gf prime would be 2y. The derivative of y squared is 2y dy dx. Basically, whenever I'm doing a derivative of a variable that is not that x, so like we're doing d dx, whenever you're doing the derivative of a variable that's different than x, you have to add this at the end. And that's easy to forget. Now we need to solve for dy dx. So I'm going to keep any term that has dy dx on the left. And on the right-hand side, I'm going to move everything that does not have a dy dx. And that's solely because I'm trying to solve for dy dx. So I group them together. So I guess minus 2y minus 1. And the trick here, when you have two of them, is to factor it out. If you factor out dy dx, then it actually becomes only one of them. And then if I want to solve for dy dx, I divide by this whole parentheses. Yep. I'm just using this notation because that I believe that's traditionally how Khan Academy, and I guess I should say more how AP Classroom probably will use it all the time. But absolutely, y prime is usually, like on the AP test, they'll accept y prime instead of dy dx. Okay, from this step, we don't need to change it at all. What I will say is on multiple choice answers, you always will see that they, for whatever reason, they can't stand having negative terms leading. So if this was a multiple choice exam, what they would do is they'd factor out that negative up front, and then the numerator would become positive 2y plus 1. I mean, to me, it's just minor, stupid details, but this is always how you'll see it on multiple choice exams, is they just don't like having the leading term be negative. Now, for this question, it actually doesn't matter at all. Because on this question, the original problem said to find dy dx at a certain number, at a certain point. So our goal is going to be to plug 2, 4 in place of x and y. Now, I can't read my own handwriting. I think I wrote 2, 4. Is that supposed to be 2, negative 1? Whose was it? Dan, I think. Okay. So, negative 2 times 4 plus 1 over 2 times 2 minus 2 times 4. And what would that be? 9 on top, 4 minus 8 on bottom, negative 4. So 2 negatives make this positive 9/4. God, that's terrible writing. I'm not happy with myself. Obviously, most of the work is going to be trying to find the derivative. And then if they ask you to find the derivative at a point, then you just plug those numbers in your end answer. The one on the test is just the derivative for implicit differentiation. So on the test, I would accept this answer, or what happens is if you decided to bring dy dx's to the right-hand side, then the answer would be exactly opposite. So as long as you have the same information, but plus and minus signs different, those are all acceptable. And absolutely ask away if something up here is not making sense, or if somebody wants me to just do a different question for you. Like 9? Yes. Oh, what happened? There we go. So this would be essentially somewhat the question itself. Is there anything in particular you were like looking for? Okay. Well, the worst part is knowing the formulas. And I'm bringing them up on my other computer right now. I'm not even going to pretend that I remember them all. Because they're all very close, and they're not easy to remember. They're not easy to memorize. So this is definitely a great spot for me to remind you guys that I hope you're making up a cheat sheet or a note card for every formula from Unit 3. I mean, inverse trig derivatives are easily one of the most important things to put on your note card or cheat sheet because they're not easy to remember. Now, you do only have to remember the main 3. You have to remember arc sine, arc cosine, and arc tan. You do not have to know the other 3. I'll put a U there. I'm bad at writing the angle. Okay, so the one I wrote here was arc sine. And they're either going to write the word arc or they're going to write this little -1 symbol. It means the same thing. They use them interchangeably for whatever reason, and it's kind of annoying. So first thing I would do is I would write down the formula for arc sine. So the derivative of arc sine of u is 1 over 1 square root of 1 minus x squared, u squared, and then times du. Okay, so there's the generic formula. Now, the only work you have to do, actually sounds like a really bad pun, it was not intended. The only work that you need to do is to figure out what u is in the problem. So if we've got arc sine of u, in our problem, that would be x squared, because it's the angle. So our derivative is going to be 1 over square root 1 minus, and then u is x squared. So we have to do x squared squared, which would be x to the 4th, times the derivative of x squared. So then this would become 2x on the top of the fraction over 1 square root of 1 minus x to the 4th. Now, this square root cannot simplify because of the subtraction. So I know some people will want to do the square root of x to the 4th, but you can't because of the subtraction. Lauren, help me out. What could make this problem harder? Like, say my original problem. The original problem I wrote was arc sine of x squared. What is something that could make it harder? Okay. One thing is you could have a multiplier in the front. If there's a multiplier in the front, the only difference is that your derivative would have the multiplier on the derivative. The other thing that could make this more difficult is it could be part of chain rule. So let's say, so that's why, Dan, I guess I'm showing you a straightforward one. It could be given lots of ways. A harder version could be if you have arcsine as the chain rule. So then this would be like u. So then your derivative would be 3 times arcsine of x squared times the derivative we just found. So there's definitely things that calc is always famous for. Every question feels different, and that's always what I hear. The questions we do together aren't always the same questions you're going to get, and that's for sure. So what I try to do is I always purposely try to teach you how things are made or come up with. I try not to harp too much on copy this, because it absolutely you'll get killed as you go to a problem that looks totally different, even though it has the same setup. So like this problem I wrote on the bottom in blue is actually pretty much identical to the problem up on top in green. Even though they look 100% different, and they feel different, the majority of the work on this problem in blue is the derivative at the end, which was what we did in the green. So for arc trig derivative, inverse trig derivatives, don't spend all your brain power in trying to memorize the derivatives. Write them down, have them memorized, write them down so that you can use them from the note card. Use your brain power trying to figure out how to lay out a problem. Anything else from the outline maybe somebody wants me to do for you? Find derivative from an alternative form of derivative at a point. Yes, I can. I think that was one I did in the notes on Friday, but I will just do another one. Now this one's actually probably a lot more obvious. I'll come up with a totally different one here. I'm trying to do it that's work in my head. It's not going great. Oh, let me change this number, otherwise the problem becomes a little harder. So this is generally how the question is going to be laid out and given to you. And you should recognize that it's built from the formal definition of a derivative. So the formal definition of a derivative was f of x plus h minus f of x all over x plus h minus x, which comes out to be just h. Now, this is how to find a general derivative. If you want to find the derivative at a point, like at x equals 3, then what you would do is you would put 3 in place of x. So that's how these two problems are set up. What you need to do is you need to identify what was the original function and at what number are they asking for the derivative. Those are the two things you're trying to figure out from these problems. Now, I tried to make them look very different. I'm hoping I did. The one up on top, who should I go with? Lauren Mortensen. I always forget the two Laurens are right next to each other, too. Wait, which one answered last time? Lauren Garrity answered last time? Okay, Lauren Mortensen. I don't know which would be easier for you to answer. What's the function that's being talked about here? Or what's the x value? Nothing? I'm pretty sure you can tell the x value, actually. Because there's only one number written there. 2. Okay. So the one that I would focus on is often this second half. It's easier to identify. Obviously, there's a 2 there. That's going to be the x value that you're being asked to find the derivative at. Now, the function, I don't know if it's easier for you to look at the first one or the second one. The function is going to be e to the x. Because I've got the h plus the number right there, that's basically where the variable was. So the function is e to the x. So we're being asked to figure out f prime of 2. That's what this problem in green is actually asking us to find. So the derivative of e to the x is e to the x. That one's the easiest derivative of all of them, but it's the one that always feels like you're doing it wrong. And then I'm going to plug in 2 into my derivative. And then that would be my answer that I'd give. Now, number 11, I kind of purposely tried to write because it's harder to see. On number 11, you need to figure out the equation before you can figure out the x value. Up here, it was easier to see the x value because e squared, I mean, like 2, you could tell was what was plugged in. Down here, you can't because of the equation. So this is going to come from x squared minus x. Basically, wherever this h plus a number was, is what you can tell where there was a variable. So the equation was x squared minus x. The x value is easiest to tell from right there. Whenever it says h plus something, that's going to be the x value. That'll be the easiest to tell from there. So this one was also x equals 2. So my derivative is going to be 2x minus 1. And if I plug in 2, I get 4 minus 1, or 3. Now, I'm purposely trying to write all of this info for you because you're not always asked to find this final answer. Sometimes you're just asked what was the original function, or what was the x value that's finding the derivative at. So you could be asked different questions from the same one. Okay, hope that helped. Is there anything else somebody wants me to go over? You guys look like you're feeling drained right now. Are you trying to tell me that calc is not what you wanted to do at 8:30 in the morning on Monday, on a rainy day? This is supposed to wake you up. Should I mimic everybody's pose right now? Do you guys want me to be done? Do you want some time just to try to work on things? I can do that. We've got like, what, 20 minutes left? You guys, if you guys are working on things today, you'd be more than welcome to just send me a picture of your questions, or, write out your question. I can try to help you out. I've gotten quite a few of them like that already. People just take a screenshot of their Khan Academy question they've had trouble with. And it's usually not a bad way to do it. Okay. Go for it. Sorry, you're right. So on the original derivative question, the second half of the top is minus f of x. So if I plug x equals 2 into x squared minus x, I get x equals 2. Like it kind of worked out bad, but it was also 2. So this is saying minus f of x. So it's minus, and then whatever number I plugged in. It actually works out the same up top. If I plug 2 into e of x, I get e squared. So this was minus e squared. You're right. The whole reason I picked this example is because this number right here feels misleading because it feels like you don't know where it comes from. Good question.